Assalamu alaikum and very good day. My name is Dr. Javed Iqbal. Welcome to my new video on HDFS architecture. This is part 4 of my videos on Introduction to Apache Hadoop lecture series. If you have not watched my earlier videos on Introduction to Apache Hadoop, you may watch on my YouTube channel or the links given in the description. The focus of this slide is to show you the architecture of HDFS. As we have seen in my last video on Hadoop ecosystem, that Hadoop 2.0 has different components. The name of those components are HDFS, Yarn, MapReduce, and other components. HDFS is one of the major components in Hadoop 2.0. In this slide, we will see HDFS architecture and its various components. First, we will see what is HDFS. HDFS is Hadoop Distributed File System. HDFS is the primary storage system of Hadoop. HDFS stores very large files running on a cluster of commodity hardwares. HDFS provides high throughput access to the application by accessing in parallel. HDFS has two components, name node and data node. Name node resides on the master machine while data nodes resides on the slave machines. Next, we will see the major tasks of the name node. Name node stores metadata, that is the number of blocks, replicas. Metadata is the directory tree of all the files in the file system and tracks the files across the cluster. Name node also maintain and manage data nodes. It assigns tasks to the data or slave nodes. Name node should be deployed on high-end and reliable computing machine. Next, we will see the data nodes. Data node resides on the slave machines. These slave machines may be commodity hardwares. Here I have shown you the architecture of data nodes in a cluster. Suppose here, if we look into this diagram, we can see that name node is connected to the core switch. The core switch is connected to the different racks through network switches. There are different number of racks in a cluster. Since Hadoop works on a cluster, so this HDFS depends a lot on the working of the cluster. Name node is connected to our core switch. Next, core switch is connected to the different racks and each rack contains different data nodes. So in this example, rack 1 contains data nodes from 1 to 10. So we can say that rack 1 has 10 data nodes. Rack 2 also has 10 data nodes. Similarly, rack n also has 10 data nodes. So in our case, every rack has 10 data nodes. The rectangles in each data node shows the blocks. Since HDFS divide data into blocks, these are the different blocks of data. I have shown a distinct block with different color. So in this diagram, I have shown the architecture of data nodes in a network. So the working of HDFS greatly depends on the performance of a cluster. So here we will also see the major tasks of each data node. Data node stores the business data, creating, replicating, deleting, retrieving data blocks as per the instruction of master node. Data nodes perform read and write operations as per the request of the clients. Data nodes should be deployed on a commodity hardware. Commodity are the low-cost computing machines. Data node is a block server that stores the data in a local file system. Lastly, the most important thing, name node and data node are two daemons or processes that run on master and slave machines. As we know that Hadoop is a framework to process big data. The Hadoop works in distributed environment. The ultimate task of the Hadoop is to get reliable and fast computing. And the centerpiece of the Hadoop is the HDFS. Two major components of HDFS are name nodes and data nodes. Name nodes works on the master nodes while data nodes works on the slave nodes. This slide shows the working of HDFS components, that is name node and data node. Furthermore, in this slide, I have shown the complete architecture and working of HDFS. Here we have a name node. In addition to previous name node also perform few other tasks. Since name node is a master node in the HDFS architecture that maintains and manages the blocks stored on the data node. Name node should be a very highly available server that manage the file system namespace and control read-write access to the files by clients. Here we have a name node. Name node stores metadata. Metadata is the data about data. That is, it stores the name of the files, their replicas, permissions about a file, ownership of the file, and detail of the hierarchy directories. Next, we have data nodes. Data nodes resides on a cluster of commodity hardwares. Here we have different number of racks, and each rack have different number of data nodes. As we can see that name node can perform a read request for data based on the request from the client. And name node also performs the metadata operations on the data. The information about metadata is stored on the name node. Next, name node is also responsible for writing data on different data nodes on the request of the client. Next, in the cluster architecture, since there can be different data nodes on different racks, the blocks of data can be stored on different data nodes. In this figure, I have shown different data nodes on different racks. Each data node contains different types of blocks. Here in the figure, the color of each block is shown a different color. So similar block may have similar color on different data nodes. While we replicating blocks, name nodes store different blocks of data on different machines. Name node perform block operations on the data. At the bottom of this figure, I have shown different types of information related to HDFS. First one is the block size. Since HDFS deals any data in the form of blocks, so whenever client submit a request, the HDFS divides the original file into blocks. Default block size is 128. These blocks are stored on different data nodes in the cluster. Next is block replication factor. Each block of data is stored on different machines in the cluster. The default replication factor is 3. The blocks are replicated on different data nodes using rack awareness algorithm. Rack awareness algorithm tries to place blocks on the nodes so that the chances of failure can be reduced. The next is data node health status. Each data node sends heartbeat to the name node after every 3 seconds. So, if after specific time the name node did not receive any request from a data node, so it can be assumed that there might be some problem with the data node. So in case of failure, name node assign the designated task to some other data node. Apart from the name node, there is also standby a secondary name node. A secondary name node stores regular backups of name nodes. So in case of active name node failure, standby a secondary node can be used. As we have discussed that metadata is also stored on name node. Metadata maintains two types of files. First is the edit logs. Edit logs maintain transaction log to record every changes in the HDFS file system since last FS image creation. Lastly, create new image based on recent image. Next is FS image. FS image contain name of the file system, namespace since name node is up. Lastly, in this video, I have shown you the architecture of HDFS. We have seen that there are two components of HDFS, name node and data node. There is only one name node and there can be multiple data nodes in the cluster. HDFS is the storage system of Hadoop. Every activity in the cluster is maintained in the name node, and name node also manages everything related to data processing. The data nodes are only the processing nodes. In this video, I have shown the architecture and components of HDFS. I hope you will understand the working of HDFS through this video. Thank you very much for watching my video. Stay tuned for more videos.